I think the quiz is pretty fair. I just glanced at it. It's off your WebAssign. So if you're not caught up in your WebAssign, it's definitely stuff off your WebAssign. But let's do the polar coordinates one first, since I did see that. So it doesn't feel like it. But the whole goal is to change variables, so integration is easier. That's the goal. It doesn't feel like it because in classes, you're used to doing things in rectangular coordinates, and then all of a sudden you're asked to do things from polar coordinates, and you don't know, like it just feels like, oh, I don't know I got to go back to my unit circle, I got to go remember my pre-calculus, and it feels really painful. But the real reason is that we are trying to integrate something. It's not pretty in rectangular coordinates. It's easy in polar coordinates, so we make the transformation. That's the point. So the problem that you're given, your f of x, y, not you're given, I made it up, so I'm giving you, and over area, and it's the first quadrant integral, let's see, question? It's just D. It's a period. It's a new sentence. D is the first quadrant area bounded by the circle and the axes. So step one, what do you think step one is? Draw the region. Anybody not drawing the region tomorrow, I'm just going to come by and like that at the back of the head. And then you'll know, oh, I'm supposed to draw the region. Think of it as just partial credit that you're going to get. It won't hurt. I'm not that strong. There's my region, first quadrant, circle with radius 3. Bless you. I want you guys really to pay attention and ask me questions if you don't know what's going on, because now that I see this on tomorrow's thing, I want to make sure everybody's got this. No, we did not do polar coordinates last class. We did it with rectangular coordinates, right? So now you got to rethink this. From last class to this class, what you have to rethink is, there we were going in rectangular motion. So we're looking at vertically where it strikes the graph and how it exits, and then horizontally where it strikes that. Here you got to go from radius and angles. So if I shot a radius through here, it strikes the picture at radius equals 0 and strikes out to radius equals 3. And your angle, there's two variables. And the idea here is that the first problems that they give you in polar coordinates and pre-calculus, which you don't remember, is that they have you take a rectangular coordinate and then change it to polar coordinates. Every point on the plane can be thought of as being on a circle somewhere. If you just drew spiraling circles. And there's even graph paper with circles on it. So that's what you're doing. So where does your angle go? Start and end. Come on, pre-calc people.
45 degrees.
Well, that my arrow shot at 45 degrees, but in this picture, where does your angle start?
0.
0, and where does it end? Yes. So it's 0 to pi over 2. So keep them in radians. You were correct. You just want to keep it to radians. And the reason you want to keep it to radians is, in math, if you actually take your circumference around the circle, the unit circle is 2 pi. It's exactly 2 pi. I do this little experiment with kids, having them take round things and go circumference and then take the diameter and divide 2, that you get pi. So it is actually pi, which is kind of cool. So step 2, rethink shape in terms of r and theta. Second step, you're going to make the transformation in your original integral. And the x's are cosine theta, just like you remember from when you were in pre-calc. It was just cosine theta if it was the unit circle. But if it has a radius, it's r cosine theta. And I think you did that in this class, right? Polar coordinates. And so, and then y was r sine theta. The only thing you have to remember is that is the same. So you're going to change the x and the y up, and dA is equal to r dr d theta. If you want the reason, let me know when you're free. I'll go through the proof. It's in your book. We use Jacobians, and it's really cool. So let me write that neater. That. It's r d theta. And in case you forget, there was a captain back here when I was teaching in 96, and he used to say, think like a pirate, r d theta. And I remember him saying that and thinking, that's so corny, but I remember it. I'll tell him I talked to him. Be a pirate. Right? So you just have to remember that that's what it is. Don't you get to bring in a sheet? Yeah, you put it on your sheet. Sadly, that's a gift. All right, so then you pop all this back into your integral. I did the r first here. In the PDF I sent you, I did the theta first. It doesn't matter because they're both, it's like circles in the polar world are like squares and rectangles in the rectangular world. So you can switch the order, and I did. Like that. You just pop it all in there. This part here is your x. This part here is your y from your original function, and this part here is dA. The only thing is, if you're writing r here, this and the dr have to come first. Because you're integrating, this tells you that you're integrating with respect to r first. And then you integrate this, and it doesn't look better, does it? But I swear it is. Let's simplify this a little bit. I'm going to take this 3 outside. Just a little bit better. And this is a theta here. Like that. All right, so I have r first, so it's going to be r to the 5th divided by 5. All this stuff, ugly as it might look, it's just a constant. If I'm integrating with respect to r. So I'm going to get r to the 5th over 5. And I'm pulled that 5 outside too. So I'm going to change colors. I got to do that evaluation. I'm just trying to keep everything in one spot. So just either you have to do the inner integral separately in the PDF. Instead you did the inner stuff first and then I did the outer stuff. I split it out. Or you have to keep good books. I'm trying to keep good books. If I pop this 3 minus, if I do the fundamental theorem I calculus here, I get 3 to the 5th minus 0 to the 5th. So it's just 3 to the 5th. You see that? You sure? I skipped some stuff last class and it was like, I lost them. Oh, wait. Got it? Got it down? No texting your friends. What is it? Oh, you're multiplying things out?
I just did 3
Oh, what is it?
243.
All right. We're going to have to put more numbers together. I left them all outside. All right. Would have been better if you were texting your friend. It's a better story. So I'm there. I got one more 3 to multiply n. Now this is u substitution. That's what they said too. So I'm going to do it slow. Your u is cosine theta. Your du is minus sine theta d theta. If you're not a fan of u substitution, think of it as substitution. This is your u, and over here you can solve for your d theta like this, and then plug everything back in, and everything should cancel out.
How do you know which ones are used? Like,
Honestly, I've done so many of these. A second I see a cosine and a sine, I use the I know the derivative of cosine is sine, so I know that the sine has to be the du part, which means the u part has to be the cosine.
I remember there's like an acronym for that. I don't know how it's
I just have done so many of them. I've got a really exciting life. So my revised integral is this thing, the numbers on the outside, theta equals, oh, let me drop that out. Yeah, let me leave this as is. And there's a negative that comes from here. I'm going to pull that outside. I just pulled the negative out front. Last class freaked out when I did that. So this minus sign here, I just pulled it out to the front. Every time there's a constant, I just throw the constants out the front. And now I can integrate that. That's minus 3/5 times 3 to the 5th times u was really cosine theta, and that's cubed over 3. I'm going to put the over 3 on this side again, throw it outside. Okay, again, tracking what I'm doing. All I did is, this is u cubed over 3 when you integrate it. So I did the over 3 out here. I just threw it again outside. All numbers are just going to the outside. And now I can plug this in.
Why does the 3 only have to go on here?
Well, you're multiplying. You're multiplying by a third, so I just do the third outside. The negative, this thing.
Yeah.
So it used to be the d theta is the u divided by minus. This is minus 1, so I pulled the minus 1 on the outside. So there wasn't a minus sign before that interval, now I pulled it out to the front.
So you just,
The minus sign could stay in here.
I understand that, I just understand this sign. You just multiply it by, you just found 5 over 2. Negative sign 5 over 2. Negative 1, you just multiply it outside.
This negative sign here?
Yeah.
Yeah, I just pulled it out to the outside. So this negative number came from here.
Oh, then you just did the other.
The cosine was u. So what happened was this part became u squared, and this part is minus du. So I have u squared and du, the minus sign I took out to the front. Tracking?
Yeah.
Okay.
I thought you saw what you're saying.
No, yeah, I know. Everybody thought that in the last class too. You're not the only one. And now I'm ready to punch it in. So I get that. And now you can punch out that number. I can tell you what it is because I did it. I get 243 over 5. So this should be 243 over 5. All right. I want you guys to try one of these. So everything's in these PDFs. The board problems I give you, the board problems I don't give you. I try to make something up like every one of your rep assigns so that you have something to look off of. So let's go try. Oh, actually, it's 243 over 5. Let's try one yourself. Oh, that's polar coordinates. Let's see. Try a board problem. Try that one. Take boards, give it a shot. You have my notes now to launch off of.